The internet is not a cloud, not a single entity, and certainly not magic. It is a vast, decentralized network of interconnected computers spanning the entire globe, communicating through standardized protocols to exchange information at remarkable speeds. At its foundation, the internet operates on a client-server architecture. Your device, whether a computer, smartphone, or tablet, acts as a client requesting information. Servers are powerful computers that store and deliver this information upon request. This relationship forms the backbone of every interaction you have online. When you access a website, your request does not travel as a single continuous stream. Instead, it is broken down into small units called packets. Each packet contains a portion of your data along with metadata, including the source address, destination address, and sequencing information. This packet switching methodology allows for efficient use of network resources and provides resilience against network failures. These packets traverse the internet through a process called routing. Routers are specialized devices that examine the destination address of each packet and determine the most efficient path to send it along. The packets may take different routes to reach their destination, passing through multiple routers and networks. Once all packets arrive, they are reassembled in the correct order to reconstruct the original message. The physical infrastructure supporting this digital exchange is extensive and tangible. Undersea fiber optic cables stretch across ocean floors, connecting continents. These cables transmit data as pulses of light, traveling at approximately 2/3 the speed of light in a vacuum. On land, a combination of fiber optic cables, copper wires, and wireless transmission towers create the pathways through which data flows. The Domain Name System, or DNS, serves as the Internet's address book. When you type a website address into your browser, you are using a human-readable domain name. However, computers communicate using numerical Internet Protocol addresses. DNS servers translate domain names into IP addresses, allowing your device to locate and connect to the correct server hosting the website you wish to visit. The Transmission Control Protocol and Internet Protocol, collectively known as TCP/IP, form the fundamental communication protocols of the Internet. IP handles the addressing and routing of packets, ensuring they reach the correct destination. TCP manages the reliable delivery of data, verifying that all packets arrive intact and in the proper sequence. If packets are lost or corrupted during transmission, TCP requests retransmission. When you browse the web, the Hypertext Transfer Protocol, or HTTP, governs the exchange of information between your browser and web servers. Its secure variant, HTTPS, adds encryption through transport layer security, protecting sensitive data from interception. This encryption ensures that information such as passwords, credit card numbers, and private messages remain confidential during transmission. Data centers house thousands of servers that store and process the vast amounts of information accessible through the Internet. These facilities require substantial cooling systems and redundant power supplies to maintain continuous operation. Content delivery networks distribute copies of frequently accessed data across multiple geographic locations, reducing latency and improving load times for users worldwide. Internet service providers act as the gateway between individual users and the broader Internet infrastructure. They maintain the local network infrastructure, assign IP addresses to customers, and route traffic between their networks and the global Internet backbone. Peering agreements between ISPs and major networks allow data to flow seamlessly across organizational boundaries. The Internet functions as a layered system, with each layer providing specific services to the layers above it. The physical layer encompasses the actual hardware and transmission media. The data link layer manages communication between directly connected devices. The network layer handles routing across multiple networks. The transport layer ensures reliable data delivery. The application layer contains the protocols and services that users directly interact with. This intricate system of protocols, hardware, and infrastructure operates continuously, processing billions of requests every second. The Internet's decentralized design provides remarkable resilience, as data can route around failures and congestion. What appears as instantaneous access to information is actually a complex choreography of packet transmission, routing decisions, and protocol negotiations occurring across a global network of interconnected devices.